Hi, this is Dr. Lesher, and this is the first video for Chem 103. It's about scientific notation. In chemistry, we talk about really small things all the time. And scientific notation is a great way to start to quantify those really small numbers. It's just a lot more convenient than writing a decimal point and tons of zeros. If you think about it, our subatomic particles in chemistry are 10 to the minus 15th meters in diameter. Just as a scale, that's a whole lot smaller than even something like a cell. So let's look at some examples to try to figure out the scientific notation stuff. A red blood cell is 0.000007 meters in diameter. To express that in scientific notation, it looks a lot nicer, 7 times 10 to the minus 6 meters. And then there's a whole lot of them in the human body, values right here. 2 times 10 to the 13th red blood cells in the human body. So with scientific notation, we talk about the coefficient and the power of 10. Coefficient is simply that first number, the 7, and the power of 10 is that exponential term there, 10 to the minus 6. Over here, our coefficient is 2, and 10 to the 13th is the power of 10. So that's a bit of vocabulary. Let's talk about going back and forth between scientific notation and decimal notation, which you're probably a little more comfortable with. Really, it's just a multiplication. When we look at a number in scientific notation, we're multiplying that coefficient by the exponential. It's good to think about what this power of 10 really means. 10 squared is 10 times 10, which is 100. So really, we're just doing 8.23 times 100. And 8.23 times 100 is 800 and then 23. You can see that I'm really just moving the decimal place 2 spots, and that corresponds with the 2 in the power of 10. Down here, if I've got 4 times 10 to the 5th, I'm still moving that decimal place to the right 5 spaces, 1, 2, 3, 4, 5. Even though there's no numbers in those spots, I'm filling in all those spaces that I moved the decimal place with zeros. Then lastly, in this example, if I have a negative exponent, that means basically that I'm dividing by, in this case, 10 to the 4th, or 10,000. And when I divide 5.5 by a much bigger number like 10,000, I'm going to get a small number, something in between 0 and 1. And so that 4 is representing how many places I'm going to move the decimal point, and this time I'm moving it to the left. 1, 2, 3, 4. And again, filling in those empty spots with zeros. Most common mistake I often see with this kind of conversion is wanting to add 4 zeros in here. But remember that you're moving the decimal point 4 places, so there ends up being 3 zeros there. Going the other way, going from decimal notation to scientific notation, is really just kind of the same thing. In this case, the first step is to rewrite the number with a decimal point after the first digit. So that first digit's the 2. I'm going to write 2.36. Now we know these two numbers aren't equal to each other, so we have to fill in with that power of 10. And the question is always, what's my exponent? And the exponent should be equal to the number of places you'd have to move the decimal point to get from this version to this version. So if I count that up, that's 1, 2, 3, 4, 5. So that means that my power of 10 is 10 to the 5th. Same thing here. I'm going to rewrite this as 1.4. And my power of 10 here, this is a small number, right? This is one of those in between 0 and 1 numbers. And so to move the decimal point from here to after the 1, 1, 2, 3, 4, I had to move it 4 places. And so my exponent here is going to be negative 4. So summary, if you're moving the decimal point to the right to get from decimal notation to scientific notation, it's negative. If you're moving it to the left, then it's positive. But the way that I usually look at it is like this. If your value is greater than 1, it should have a positive exponent. If it's less than 1, it should have a negative exponent. I want you guys to be able to multiply numbers together just using your brain, not your calculator. And in scientific notation, that's not too hard. So if I've got these two numbers and I'm trying to multiply them together, the first step is to multiply the coefficients. That's our 2 and our 1.5 there. I should remember that. So what's 2 times 1.5? 3, right? And then you're going to add the exponents in the powers of 10. So you're going to have that power of 10 in the answer. And the exponent should be -5 plus 3, which is -2, right? So it's as simple as that. With division, we're going to kind of go in the opposite direction. We're going to divide the coefficients, and then we're going to subtract the exponents. So if I divide 9 by 2, I get 4.5. And then my power of 10, I'm going to subtract the exponents. So 4 minus 9 is -5, right? So yeah, it's as simple as that. Now I won't have you be doing 3.88 times 1.75 in your head. But even in a situation like that, you can round and approximate what your answer should be, and then check it on your calculator. Okay, so let's do some practice. This first set doesn't have any coefficients, so these are really easy to do in your head. If we're multiplying, we're adding the exponents, right? And on this slide, I've written out sort of what it looks like if you were to be doing this in decimal notation. To me, it's a whole lot messier. So 10 squared times 10 cubed is really just 100 times 1,000, so that would be 100,000. But in scientific notation, all I need to do is add that 2 and 3. So that would give me 10 to the 5th. I'm not going to write the answers for all of these. Here, again, if I'm multiplying, I'm just adding the exponents, but look at that. That's pretty messy to look at. If you've got all those zeros that you're trying to keep track of, it's really easy to make a mistake. But if we're just adding these exponents, 10 to the power of -11. Dividing, we're going to be subtracting the exponents. So 1,000,000 divided by 1,000 is going to give us 10 to the 3rd power. Starts to get a little, you got to use your brain a little bit here when you start getting negatives. If we're subtracting our exponents here in division, 6 minus -3. 2 negatives is a positive, so this would give us 10 to the power of 9. 10 to the -2 divided by 10 to the -6, -2 minus -6, that would be 10 to the 4th. So a few more practice for you guys to do here, and let's do this first one together. Remember our strategy, multiply our coefficients together. What's 3.2 times 3? 9.6, right? And then our exponent, 10 to the power of 6. 3 times 5, that's an easy one. That gives us 15. And then our exponent here is 10 to the 2nd power. Now, we don't really want to leave this one like this. It's just not proper scientific notation to have a coefficient greater than 10, 10 or greater, really. So I want to do kind of what I did before, and that's to change that 15 into 1.5. Now, to do that, I had to move the decimal place one spot, and so I'm going to add that power of 10 to the exponent. So rather than 10 squared, that would be 10 cubed. 15 hundredths is the same as 1,500 or 1,500, which I've expressed here. 2 times 4.1, that gives us 8.2. And adding my coefficients, oops, that's not an equal sign there, times 10 to the -15th, really small number. And one last division, let's do this one together. 9 divided by 2 is 4.5, and our exponents are now subtracted, so 10 to the 4th. So hopefully this gives you a good set of skills to use, and on your packet you will have some extra practice ones to work on. Thanks.